You've reached the Occasional Podcast, Season 13, Episode 2, a very, very special podcast where we look back over the years and bring back some of the best clips aggregated together from some of our best interviews. In this episode, you will hear from some of the biggest voices in audio. So I thought, why not kick it off with one of the more prolific conversations that keeps bubbling to the surface? Measurements.
Measurements in HiFi. Why, oh why? Are there so many measurements in HiFi? Enough to reach the sky.
So all of these clips are taken from previous episodes, which you can look up and listen to them in their entirety. But we stretch all the way back to Season 3 on this, so we're on Season 13 now. I wanted to put together a collection of thoughts that show a couple of different things. Not just statements about measurements and how they relate to hi-fi, purchasing, products, and design. But also, I think it's equally important to listen to these designers and hear what direction they're coming from. Their approach is almost equally as important as how they utilize measurements. The first clip is from a very important mind in the landscape of hi-fi, Peter Comaeu, Director of Acoustic Design at IAG. So this is a brand that manages huge influential brands, Wharfedale, Mission, Quad, Castle, and Audiolab. He oversees all of these sounds. And he has a very pragmatic approach to measurements, I think. Today's episode of the Occasional Podcast is sponsored by Audio Vision San Francisco. Located in the heart of the city by the bay on 1628 California Street, Audio Vision is a brick-and-mortar retail location that has been delivering some of the best sounds in hi-fi to Northern California for over 26 years. Come celebrate with Audio Vision on October 18th and 19th at their huge in-store listening and learning event with 4 full demo rooms with gear from brands like Goldman, YG Acoustics, Nordos, Inuos, REL, and more. The 2-day event is free to attend, and you can find out more details on their store site, www.audiovisionsf.com. Today's episode is brought to you by Pass Labs. For over 3 decades, Pass Labs has delivered unparalleled sound quality. Solid-state amplifiers designed by legendary engineer Nelson Pass and preamplifiers designed by Wayne Colburn come together to bring warmth and transparency to your audio experience. Handcrafted with precision and passion in the U.S., our world-class service department is here to ensure your Pass Labs products bring you joy for years to come. Listen with Pass Labs and discover your music like never before. For more than 25 years, Music Hall has been helping listeners discover and rediscover the magic of vinyl. Their line of turntables is built for every step of the journey, from your very first deck that gets you hooked, all the way to the last turntable you'll ever need. Each model carries the same commitment to musicality, precision, and lasting value. Simple to set up, a joy to use, and engineered to let the music shine. Music Hall turntables make analog playback accessible without ever losing sight of performance. Whether you're just starting your collection or refining a lifelong passion, Music Hall has a turntable designed for you. Find your perfect match at musichallaudio.com.
Yeah, I've gone on record to say that the only measurements that matter are the ones that matter to the designer. You cannot.
I like that one.
You cannot assess a loudspeaker from measurements. It does not give you an idea of the musicality of the loudspeaker. It only tells you a broad brush approach as to whether the designer has got things relatively right. I can, when I'm designing loudspeakers, I will generally go through between 15 to, in one case, 174 crossover designs. Each of those designs will measure well because they're based upon measurements that I've made of the drive units and in the cabinet and so on. So they'll all measure great, but they'll all sound completely different. You know, and if we take the case of 174 crossovers. That was an extreme case where I had 2.5 years, thanks to COVID, to potter around and really work hard at refining that particular loudspeaker design. And people are surprised when I show them the measurements because they look essentially the same for all of the 174, but I can tell you every single crossover sounded different. So measurements, I don't think play any relevance in the assessment of a loudspeaker for the end user. What you can tell from the specifications is a rough idea of how low the speaker goes down in the bass, for example. The minus 6 dB point is generally gives you an idea of what you can expect from the loudspeaker to go down to in the room, whether you need a subwoofer or not, for example. The other aspect you should look at is sensitivity, because that will dictate what amplifier power you're using. So if you've got a speaker with a sensitivity of 82 or 83 decibels for 1 watt and you're using it in a large room, you're going to need a big amplifier in order to get the dynamics, and you're going to have to make sure that the speaker can handle those sort of dynamics. On the other hand, if you've got something like the Super Linton, which is 90 decibels for 1 watt, then you know that you can use a tube amp very successfully with those speakers. Apart from that, I don't think anything else really makes much sense in terms of what the music's going to sound like when you get the speakers home.
Now, measurements have always existed in articles for loudspeakers, like in magazine Stereophile. John Atkins and others have taken measurements of speakers in terms of what can be seen for the consumer end. In the review, the review contains measurements. You look at the measurement graphs that are provided, and you can have another information point when looking at the speaker. And they generally do a pretty good job of translating some of those measurements into usable ideas, at least. In more recent years, consumer-level measurement tools have evolved to be able to buy for relatively cheap. They get used a lot when evaluating headphones. So an everyday person can buy a pair of headphones and measurement and post it. I think some of the confusion online has been in that same translation. Are the ideas that are being disseminated from this information really genuinely helpful to the greater mass? And one of the other really interesting things that I discovered when I was putting this together was the idea of regionalism. Regionalism is something we've talked about on the show a great many times. However, I didn't expect it to come into play so much with just the talk of measurements. We'll get into that a little bit more later. Where Peter was predominantly a designer for British speaker brands, we're going to jump to a headphone designer, Axel Grell. Worked for Sennheiser for years. He helped develop some of the biggest headphones and that were initially part of the scene. The Sennheiser 650, the 600, wildly popular headphones in like the 300 and under range. And also one of the biggest audiophile headphones that ever existed for a long time, the HD 800. The HD 800 was like this flagship Sennheiser headphone that existed for so long before all the other kind of brands jumped on the bandwagon to get it really high end, and it pushed that ceiling up even higher. This was one of the first. This was one of the icons that he helped design.
Yes, I think measurements are important, but it's important that you know what you're doing. And the first thing that you learn in university when you learn about measurements, not only acoustical measurements, but all measurements, there's a failure. You always have failures in your measurements, and you have to know your failures. So it's always a limited view on things. The measurement influences the whole thing. So this is something that is imminent. And when today enthusiasts are doing measurements, some of them know very well what they are doing, some not. When I started to build my first speaker, hey, I had no idea. So it's good that this goes on and people are building up experience. The other side, the most important measurement instrument is the ear. When it doesn't sound good, it is not good. When it sounds good, it is good. And my design process is I have an idea about the headphone, about the acoustical design, and about the sound. So the target is in my head. So I have an idea how it should sound. The sound already somewhere in my head, and then I try to come closer to that. When I identify something where I say, okay, that doesn't sound the way I wanted it, I think it's in the frequency range of somewhere between 5 and 6 kilohertz. There must be a peak. So let's see, is it really there? What is happening when I bring it down? So I do the measurements, do the changes on the workbench with the artificial ear, bring that region down acoustically. Then I make a listening session and hear, is it really that peak? Or no, it's that was the wrong region, must be somewhere a little bit higher. And then I remove that again and go to the higher region and try it there, listen to it, and then, okay, that's it. So I need to keep that. So it's a iterational process, listening, measurements. Yeah, in the end, sometimes the measured curves looks very similar to what Sean O'Leaf found, sometimes not. And I think Sean did a great job in total, but it's only the beginning. Because a lot of things are not really in that curve. So when you have the acoustical impedance of the headphone, I talked about that already, is when you have an open headphone, it doesn't matter that much if you have a frame here and an opening, because there's so much air going through the open ear pad and through the open acoustic baffle already that this little openings doesn't play a role. When you have a very close, very high impedance headphone, high impedance not electrically, acoustically, and you just have a little opening, then the bass is gone completely. It's not only the openings, it is the acoustical impedance of the ear itself, and the acoustical impedance of the ear is changing with the headphones you're wearing, and that influences again the sound pressure level and the perceived sound. So there are a lot of things that are influencing the sound or the perceived sound, and it's not all really scientifically, there's no recipe where you can say, okay, do it like that, and then you have the perfect headphone. It's still a process where you need to have experience, listening experience. It's still a kind of art. It's scientific, yes, definitely, engineering, but it's a little bit of art as well, still.
So one of the things that Axel mentioned in his interview was the work of Sean Olive and Harman Kardon. As one of the few companies that have dumped a lot of money into audio research, and let's be honest, high fidelity isn't always the most predominant thing that companies are worried about when it comes to like sound quality and stuff, because it doesn't often make a lot of money compared to other things. It's always a low priority. So Harman Kardon did put some money into audio research and tried to figure out some things, which is great. And Sean Olive and his team helped develop what they call a Harman curve. And I've actually had the pleasure of experiencing that research firsthand. I got a tour of their facilities. I got to see how the process is done. It's a very interesting, very scientific process. So they developed what's been known as the Harman curve, which originally started for loudspeakers, and it kind of gave an aggregate sum of what everybody's preference was in terms of frequency response. That was the main focus, frequency response. And that's what Axel is referring to in terms of the grand sum of what everybody's preference from their research kind of came out to. The way that Harman curve changes or can be applied to headphones is also another talking point. I think it's very important in terms of just to think about how the curve applies to other people's perceptions, and it's very something that can be laid over top of what they are doing as either, you could argue, a blueprint, or maybe why their frequency response curves varies. So now we did British HiFi, we did a little Germany HiFi, and we are going to go for the next interview back to Britain. If you have listened to all the episodes, you know that we talk about Britain as being a special place in the world, in the entire zeitgeist of HiFi. And while things developed in both Japan and the US and Germany, the British HiFi sound has become a very strong force in HiFi over the years as a way of leading a lot of that specific sound that they love. So we have Andrew Jones, who is also worked at Harman and a huge litany of other companies, but was also part of a British community of designers in a very important time, I think, in hi-fi history. So here's his clip from season 12, episode 5, where he talks about his new speaker and bass and measurements.
You know, I have to say that it's Floyd Toole was the guy who brought me over here. I know all of his work through the years. You know, I worked for Harman for a while. I know all this measurement correlation to preferences. You got to understand it's not, is this speaker giving the correct sound? It's, you poll all these listeners and what is their preference each time? And preference based on listening to some commercial recordings. Who knows what was done in those recordings? So it's not accuracy to the source because you don't know what the source is supposed to be.
Also, I should mention, the tests are done in mono.
Well, there's that as well, yes. Yeah. So, in the speaker panel discussion yesterday, Sean Olive was in the audience because I knew him when I was at Harman, and he's there, and Erin is there, who's got the Klippel system. Klippel was at Harman when I was there, so I know Wolfgang, I know Sean Olive, and some of the things I was saying, we got onto this subject, measurement versus listening, and I said, the problem is whatever correlation you're trying to make, you at least need to know accurately how it measures. And I'm telling you that 99% of the people who got a computer and a microphone don't know what a correct measurement is. That it's next to impossible to push a button and get one sweep and say, this is the frequency response of the speaker, even if just the on-axis response, never mind looking at all the off-axis to correlate to audibility. I wish it was that simple. It just isn't. I've been in some of the world's biggest anechoic chambers, and you have to correct them around the 50 hertz region below. You have to use you float it up above the ground. Even 14 foot isn't high enough to get low frequency accuracy. Plus you've got low wind noise and temperature effects. You can't obviously measure in a room, and so you do ground plane. Well, that screws up the diffraction of the cabinet, so it gives you not the perfectly correct answer unless you do all this post-processing, knowing the effects of all these measurements. But how do you know you made an accurate measurement in the first place? You don't have a reference. You don't have a calibrated source to check what you're doing. So how would you know whether it's right or not? And I said, even the Klippel system does not measure the far-field response of the speaker. It measures multiple near field and through mathematics derives what it says the far-field response is while measuring in a room and rejecting some of the reflections that come back. But look at any Klippel curve that someone's done of that, and all these wiggles in the 2 to 800 hertz region, let's say, all those wiggles, they're not the speaker. They're remnants of processing out what the room is doing to that microphone. So when you got that and you see these wiggles, are those little resonances in the speaker, or is it something from the room? You don't know until you eliminate it and measure it a different way and do this. So it's not easy to know what you're doing when you're measuring something. And it's a particular beef of mine because one of my odd thing to have, but one of my passions is how to measure accurately. And I've spent a lot of time researching those kind of things. So unfortunately, most of the time, you're deriving a composite to get what you think the response is. But then, you need a lot of knowledge to know how to generate that composite. But because it's a lot of data that have to process in specific ways and add together, you're always looking at thinking, did I do it right? Is that really the response I'm getting? Because, let's say, a half a dB change in bass level over the whole bass range is quite audible and affects what the the balance of that speaker sounds like. So you better know, if you're going to work off measurements, you better know, or otherwise you'll be led to say, I'm hearing something, but I can't trust my hearing. I've got to trust the curves. And that's what kills me. Just trust the curves. No, I'm not going to trust your curves.
What do you have any type of reaction to the guys who do reviews and don't listen to the gear? Because there are some individuals out there that do reviews based on measurements only without listening response.
Listening does matter, right? Because you might have a goal of a target curve that's supposed to be the magic curve that if a speaker measures with this curve, it is the proper speaker. They never perfectly match a target curve. It's in those ways that they fail to meet a curve. I'll set a target curve for what I want to initially try and design to, but I know it's not going to meet that exactly. It's in the imperfections that define the sound character of the speaker. And we can't claim that a speaker has no sound character. Every speaker has a character. So it's those inaccuracies, those imperfections that define what that character is. And so it's my personal choice as to which ones I want to try and fix and which ones I don't or cannot afford. I can't afford to fix all of them, or else it would be a $20,000 speaker, not a $2,000 speaker, right? So I choose, I can put up with a slightly over-bloated bass. At least that gives a warmth. But I can't stand a projected mid-range because it sets my teeth on edge. Whereas other people clearly like that bump in the mid-range because I hear those speakers or other people hear the speakers and they enjoy it. So the personality, like I said, is my personality of what I want to hear from that speaker within a broad outline of the general balance of the speaker. But you never meet that perfection. It's like that Japanese concept of always leaving a little imperfection, because perfection is God, not man, kind of idea. Yeah. No, I think it's still good to kind of fix every imperfection you see, if only because it'll make it work better with every recording you're going to listen to. Yeah.
Peter Qvortrup of Audio Note UK is a polarizing character for some. In Season 10, Episode 2, our interview with him turned out to be one of the most polarizing episodes that we've ever done, which was a surprise to me. I didn't really know that going in. However, every time I go into an Audio Note UK room at a show, it sounds amazing. And I think that his viewpoint, his unique vantage point, is important to include in this discussion in measurements. So here's his take on it.
One of the problems with digital is that at noise level, it has very low resolution, if any. And we then claim that digital has this enormous dynamic range, but it's only really measured from 0 dB, i.e. from the noise floor. I have seen tests, and I've spoken to, I actually had a friend who studied the human hearing for many, many years. He was a professor at a university in Stockholm. And he wrote a couple of quite controversial papers on how he thought the hearing worked, and he was severely criticized for this. And he was very risk adverse, this chap. He sadly died quite a few years ago from motor neuron disease. But I remember some conversations I had with him about this, where he said, well, really the hearing is like a dual differential device. It listens for change. So if you have a system that has a relatively constant distortion across the band, and the distortion doesn't dramatically change with amplitude, then you don't hear it. Because it doesn't change. But if you can have a system which has, on paper and measured, very, very low distortion, but the distortion changes with amplitude and with frequency combinations, then you instantly pick it up. or most people do. I mean, there are people that don't, obviously, but those things, there will always be a spread, won't there?
So Peter brings up an interesting point here. Does the application of measurements in HiFi rely too heavily on our full understanding of both what the measurements mean and our understanding of how the ear really works? As we drill down into the scientific methods of this, do we really fully understand how hearing works? The delta, the change that Peter speaks about is really just the tip of the iceberg on how we may have evolved as a species to understand what's really ultimately good for us, good for our hearing, good for our survival. With my interview of Bill Dudleston from Legacy Audio, he expounds on this idea even further. This episode of the Occasional Podcast is brought to you by AudioQuest. All AudioQuest products, from the company's most modest parts to its most ambitious works of art, are thoughtfully designed to deliver outstanding performance and exceptional value, regardless of price. No matter how little or how much you invest, AudioQuest is made for you. Explore AudioQuest's award-winning cables, power products, and accessories at audioquest.com. Our friends at ZMF Headphones are sponsors of today's episode. ZMF is a curated collection of various sounds and styles in the form of dynamic and planar magnetic wood headphones, designed by founder Zach Merbach since 2011. ZMF has garnered an A+ recommended component in Stereophile, Headphone of the Year on Headphonics.com, and been a 2-time winner of the SBAF Golden Schlong Award. ZMF Headphones. That's the letter ZMF HEADPHONES.com. ZMF Headphones is the place to go to check out ZMF's collection and learn more. ZMF, traditional craft and modern acoustics. Today's episode is sponsored by Shit Audio. Shit Audio designs and builds audio components in Texas. Their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit shit.com. That's SCHIIT.com. There was two kind of things that popped into mind as you were talking about that. One is that there's a lot of accessibility right now in terms of measurements. They start to sell these little heads you can buy for like $250. Mm-hmm. And there's a lot of these hobbyists that are starting to do more and more graphs. And one of the observations, though, I do believe there's a disconnect between what the ability to get a graph and the comprehension to actually interpret it seem to be going in two different directions. Because a gentleman once, and I want to ask you this specific question, said, oh, look at this dip right here. That's where detail is. Do you feel that we perceive detail in a very small amount of frequency openings across the scale, or it is resolution and like a holistic kind of look?
You know, I'm going to attribute the valuation of all those things to the brain. And I'm going to tell you, your hearing mechanism is a lot more coarse than people realize. I know that they realize it's a mechanical device, and they see the classic eardrum, as we call it, in tympanum, and we see the mechanical factors and the anvil and the stirrup and so forth that people were taught about ears when I was a kid. And but when it comes down to the cilia, that the hair follicles that are being blown back and forth, if you will, in a fluid, washed back and forth, it's like shafts of wheat in a field. Yeah. If you look at that field when the wind's blowing, you know the wind's blowing west to east, but you look in that field, you can't really tell for sure, because at different points in that field, there's different pressures, and therefore it looks like the whole thing's just waving back and forth, and that's what's happening. Well, wave transmission is like that, and it's a very poorly understood phenomenon, but it has been found that we really only mechanically convey information up to the rate of 500 hertz. that all the rest of that information is the brain's ability to resolve little differences on those carrier frequencies, if you will, where it is able to interpolate and extrapolate those higher frequencies. Now, it kind of makes sense. If you made yourself a mechanical device, what do you think, as simple as an eardrum, what do you think the bandwidth of that thing's going to be? And you've got these little contacts, and then you got to wriggle the fibers, and then you got a chemical reaction that's got to generate an electrical characteristic stimulus that goes all the way to the brain. Then the brain's going to work on that. So all I can tell you is until we understand the hearing mechanism better, we won't really be able to take audio to another stage. And psychoacoustics is really where it's at.
Bill also subtly brings up the idea that we may be able to extrapolate or interpret frequency responses that may be outside what we consider to be the normal hearing range. This is also kind of one of those more controversial ideas about what can we actually hear. 20 to 20 is often considered the audible range for at least the spec sheet of many audio products. Measurements can also be used to determine distortion levels, which opens a whole nother can of worms for designers. Is high fidelity buried in poor resolution? Is high fidelity buried in distortion levels? Rob Watts is a predominant designer for Chord electronics, and I have had the pleasure of hearing him speak on many occasions. He is a very knowledgeable person who has quite big presentations that he does for his press meetings, which I find kind of awesome and hilarious at the same time. He goes deep, he knows a lot, and most importantly, he's a thinker. He's putting his time and energy against this in a very impactful way. Here's a clip from our interview with him, Season 4, Episode 2, where we discuss distortions and also a little bit further, odd and even order harmonics and how they affect high fidelity listening. Do even order harmonics sound better than odd order?
Well, you certainly don't want odd order harmonics.
You don't?
You don't, no, because they sound worse than even. Because the ear itself generates quite a lot of second harmonic distortion, and the brain compensates for that. It's cool with even order harmonics, but odd order harmonics it doesn't work so well with. But the curious thing about distortion, there's kind of 2 points that I'd like to add. The first one was the experience with Dave. So with Dave, I went through 3 or 4 different prototypes, and the objective was to make it as linear as possible so that we could measure it and we'd have distortion that was so much better than everybody else. And because a lot of my background is with semiconductor companies, they don't care how it sounds. All they care about is the numbers and the measurements. And I've always been that way inclined in terms of measurements, as measurements being important, because how do you assess transparency? You can do it through listening tests, but one way is to literally measure things and make sense of the measurements. Anyway, so I had this kind of ambition to make it the most linear DAC available. And I managed to get the first prototype, it was down to about minus 130 dB, which fine. It's very, pretty much state of the art, but it wasn't clearly better than, it was about the same as the best DAC available at that time. So it was just my ambition, and I couldn't figure out where this distortion was coming from. And that was the crazy thing. I just couldn't find out where it was coming from. So built another prototype, assessed one aspect, couldn't get that right, made it slightly better, and then built another prototype and made it slightly better, but I still wasn't getting the fundamental reason why, this thing was creating so much distortion. So I had a breakthrough and I managed to find out where the distortion was coming from. And I got a 30-fold improvement in distortion levels. That's 30 dB. So it went from 130 down to minus 160 dB on the higher order harmonics. So that was a huge change. Wasn't expecting a change in sound quality. It wasn't about sound quality. It was about making this thing as linear as possible. So I did a listening test, and I couldn't believe how much difference it made to the sound. And the funny thing about it was that in the evenings, I normally put my prototypes into the listening room and, watch TV with the kids. and the kids were quite young at that stage. And we used to watch Curious George. You probably don't know because you haven't got children yourself.
I remember from my youth, yes.
Okay. Now, the nice thing about Curious George is...
There's a man with a big hat.
Yeah. And the nice thing about Curious George is that they actually have pretty good music on it. And
you're saying it's an animated series now?
Yeah.
It was only a book when I was a kid.
Oh no. This is the TV version of the book. Okay. So and they did a feature film, Curious George, but they did lots and lots, and so he was, it was good fun, and the kids loved it. The music was really good, and I plugged in this change. Didn't tell my son that I'd made a change, and he's turned around and he said, "What have you done? It sounds so different." I thought, yeah, this is a big change. And what it changed was, and this has happened before on a number of occasions, when I've reduced distortion levels, oddly enough, the clarity and the detail resolution gets better. So I think it's dangerous to assume that because the ear is only capable of resolving, say, minus 90 dB, and so we don't need to make distortion lower than that level because that's the performance of the ear in terms of listening tests with sine waves. That's a very dangerous assumption because it's ignoring the brain's processing. So the problem with when you reduce the distortion levels, it's not about the ear, it's about the brain processing that information, and the distortion you've created in your product interfering with the brain's ability to separate sounds out. So it's about perceiving clarity and details and those kind of things. That's nothing to do with simple psychoacoustic tests of hearing with sine waves, which actually gives you quite a crude number in terms of what you need to work towards. So there's that as an issue. Second issue is I had a noise shaper that was creating a lot of distortion at 200 kilohertz. 200 kilohertz to 400 kilohertz. And it was a noise shaper FPGA issue, digital domain problem. Fixed it, listened to it. You could hear an immediate difference from changing the distortion characteristics at 200 to 400 kilohertz, which is pretty amazing because we can't hear 200 kilohertz. So how can a 200 kilohertz harmonic distortion be audible? And it's getting back down to this perception of transience again, and transient information being really important from a psychoacoustics, from a perception point of view. And when you have these very high order harmonics, it changes the timing of transience. And if the distortion is modulating the timing of transience, you can then perceive it. So you can't hear 200 kilohertz, but if a 200 kilohertz component changes the timing of a transient, then you can perceive it, because that's in band.
So again, we hear from Rob how it might be possible for us to detect changes in the frequency range above the normal hearing thing. So that is also a recurring theme for a lot of designers. How do we work within that? And most importantly, how does it affect what we hear normally? How does it equate into higher quality sound? Our last interview is with a West Coast designer, Nelson Pass of First Watt and Pass Labs. He talks about a couple of different subjects, but again, he kind of wraps it up, and I want to leave you with this. He brings it back to regionalism and how all of this might still be affected by where you're born on this planet. So there's a lot of contributing factors to the idea of hearing, measurements, regionalism all play a small part in what we perceive as good sound quality in terms of reproduction from these gentlemen who are trying to make it for us on the other end of the speaker. Recorded live at Nelson's Burning Amp Festival, where he hosts a DIY make-it-yourself amp festival up near San Francisco. You have to pardon the background noise. We actually recorded this one on a pier, and there's seagulls and waves and such in the background. But I still feel like it's a really great interview with another of HiFi's great thinker minds, Nelson Pass of Pass Labs. Do you think that a good sounding amp can measure bad? This gets into the whole subjectivist objective
Oh yeah,
thing.
obviously, because we got lots of amplifiers laying around that don't measure well at all.
Really?
Well, yeah. I mean, first specializes in amplifiers that have nothing special about the measurements.
So what is the role of measurements in amp design, do you think?
Oh, well, first off, if you're actually just trying to have a really accurate amplifier from a technical standpoint, then you must measure everything, and the subjective qualities aren't really that much of a consideration. If you are trying to have an amplifier be good subjectively, then you're going to spend a lot of time doing listening, and if you're smart, you'll probably also still be doing a lot of measuring. Even if you don't design an amplifier through measurements, you certainly need those measurements to see to it that you have conformity in any product that you make, because you aren't going to be able to listen to every piece going out the door. And not only that, but if you have a cold that day, or if something is wrong with you and you've had a bad day, it's all out the window.
I like that second comment. That is true. I feel like the way you feel can affect how you hear things.
Oh, absolutely.
It's insightful. Yeah.
But this is all psychoacoustics. It's all. I'm fond of saying, the ear is not a microphone. The brain is not a tape recorder.
Yeah.
When you look at the cognitive process that goes on with the neural networks in your brain, you realize that the ears are sending pulses to the brain. The little pickups are going at, and there's lots of them, and each one is mapped for, it's this frequency talking.
Yeah.
But this has to all get reassembled in the brain into what we perceive. There's a huge amount of work involved in that, and it goes up many layers. And there's some excellent literature on the subject, but basically the part that interests me the most is called the grouping mechanisms, there are neural networks at the lowest level when this stuff's coming in that are saying, this goes with that. This matches up to that. And there's a lot of that going on. And some small picture of what's going on gets made. And then it goes up a level, and on a more abstract part, the brain is still going, this goes with that. That goes with this over here. And then you go a little farther up, and now the memory of things starts coming into it. You go, this is like that memory.
Right.
And so on. It keeps going up, and finally, it reaches the desk of the little guy who sits behind your ears, like in those cartoons.
Yeah.
He's your consciousness.
Yeah.
And all this stuff is all in service to deliver a fine report to the little guy. And the little guy, by the way, wants answers, and he's not happy when he doesn't get them, I think. So the brain is perfectly capable of filling in the blanks so as to present a complete picture to the brain.
Yeah, I feel like people, they don't always know why, but they almost always know when something's right and something's wrong. This is what I'm used to, or this is how I perceive the world.
Yes.
And now something's not right.
Yes.
And now something is right. Oh, that's clarity to me. But they don't articulate, but everybody knows. Even the non-audiophile still can, something doesn't smell right to that.
Right.
To them.
Yes. Well, that's true. And also, interesting, the people who have researched this stuff, and there's a lot of research that's occurred and is still going on. Talk about West Coast, East Coast sound. Mm-hmm. Okay, I recall reading about a study that was done where there are things known as audio illusions, where certain kinds of signals will be perceived differently by other people.
Sure.
And so this person will hear this, and that person will hear something different. And these are well known. You can even buy records. You can even buy CDs of this stuff. The main point here is that a study was done, and they found that there was a difference in people, what region they were from. East Coast versus West Coast, as an example.
Yeah.
And then there were some exceptions to that when they played with the data a little more and looked at it, they found out that the other link was mother's regional accent.
Wow.
You could be on the West Coast but perceived like an East Coaster, but your mother had a regional accent from the East Coast.
Wow.
Now, this is something that probably bears more research yet.
Yeah.
But I found that just fascinating, and it explains a whole lot. For instance, why does Japanese taste in, say, loudspeakers? Why is it significantly different than, say, well, East Coast, West Coast?
Yeah.
Well, if you look at the Japanese language, it's really different.
Yeah.
It's the degree of accent that you might be experiencing as either a newborn or even in the womb, who knows? But
Yeah, because
We
they
all-
also
we all
talk about
perceive this stuff
European. Oh, this speaker's voice for the German market.
Yes.
These type of things.
or there's the BBC sound.
yeah, the BBC sound.
part.
Exactly. Yeah. I've really pushed a lot of people on those different. I find it absolutely fascinating. Exactly what you're saying. That different regions might have a different sound. Do you think that's?
There's truth to that.
Yeah.
I mean, I don't try to market to
towards
that.
it? Yeah.
No, and the thing about it is too is that I recognize that what I do is a specialty. It's a little tiny portion of the market. I'm not worried that other people don't see it my way.
Yeah.
That's not my problem. The market's big enough. If I have 1% of the high-end audio amplifier market alone, I'm rolling in money.
Yeah.
And so I know there's going to be about 1% of these guys definitely going to see it my way.
Yeah.
That's not a problem.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes parttimeaudiophile.com, The Occasional Magazine, the PTA newsletter, and audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE studio monitors. AI songs produced by Udio.com. If you haven't already, please subscribe to the Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.